Yeah, I see it. I still don't know about the term, so I guess I'll let you share screen so you can explain to me more about the concept.
Okay.
So yes, please start the screen sharing.
I share my screen.
Yeah. Do you have can you Google to find the concept and you can maybe explain for me from the Google material?
Okay. It said I can share my screen if you share yours.
Oh, okay. I believe I allow, yeah, you can share screen. So let me stop sharing.
Okay. Okay, you should see. Okay. My computer is a little bit slow.
I cannot see the screen.
Oh,
It's very,
but I've already shared it.
it's very strange.
I will send you a link. But what you have to keep in mind is that there are two types of variable in statistics: quantitative and categorical or qualitative ones. If it's a quantitative variable, they are either continuous or discrete. If it is a continuous, it can take values in a wide range. For example, it could be an interval 0.5, 0.001, and so on. But if it is discrete, it is possible to count the possible values. And when it is discrete, generally it is ordinal. There is an order in the values. And for the qualitative,
sorry, I have, there's some echo. So I'm not sure what is the issue.
you don't listen to me correctly.
Yes, there's some type of echo back.
Okay, let me get away from this noise. It should be better now.
Yeah, totally.
Okay. I was saying that, a minute. Okay. I was saying that there are quantitative and qualitative variables. For the quantitative one, they are either continuous or discrete. Continuous, it means that they could take values in wide range interval, like age, temperature.
Sorry, which one you say quantitative variables, right?
Quantitative variables, they could take their value in a wide range of interval, a big interval. The values will be decimal and so on. It's not possible to count them, like temperature, age, and so on.
Here, let me I'm seeing because I cannot see your screen. Oh, it's very blurry.
Let me restart the laptop and you will have the possibility to see.
Okay, sure.
The appearance of
Hello?
Qualitative categories. If it is quantitative, it means we measure numbers. And when it is numbers, the number could be a continuous value. So the values are in an interval, like temperature, or like
Sorry, can you show me in some type of documents, because I'm very bad with the statistic terms, so I need some visualize so I can get.
Okay. Okay. Quantitative data represents amount. Categorical data represents groupings.
Oh, okay. Hang on. So, sorry. Okay, could you go back again? Let me see the quantitative data. So,
Okay.
so this quiz is present categorical data, right?
Yes, it's categorical data.
Awesome. Yeah, I get it now. Okay.
The values could be A, B, AO, and so on. So it is categorical. Now, if it is categorical, there is again subcategories for categorical variables. We're talking about binary, nominal, or ordinal.
Oh,
If
okay.
give me an example of categorical variable, you know.
Category binary, you said, right? Oh, just category data.
Yes.
Which one did you meant?
Yes, a variable, if we try to observe, will be categories. But here we have the type of fluid. Is it possible for you to find an order in the values of the type of fluid? Is there an order? A, O, B, O. Is it possible to?
So from what I can see from your document, it would be nominal variables because group with no rank. Oh, wait. Yeah, group with no rank or order, right? Because basically blood type cannot rank or order, right?
Yes, there is no rank order in blood type.
So this one is nominal.
Yes, it's nominal.
Ah, okay. Oh, okay. I understand now.
Nominal level. Ratio level, it's not particularly a type of variable. It's certainly.
So I have a question. So sorry. So
yeah.
what is a ratio in interval level then? What are those?
Ordinal level, you can assimilate it with ordinal variables. An example of ordinal variable, you could say the grade A, grade B, after an exam, grade C. This is an example of ordinal variable.
Mm-hmm. Oh, okay. So my grade could be ordinal because it can order, right?
Yes, you can order the value to possible
Oh,
values.
okay. So basically, if I can order, then it will be ordinal variable.
Yes.
If I can,
yes.
If I cannot order, there's no relationship in my group. That is a nominal variables.
Yes, it's nominal.
Binary is like either yes or no.
So yes, either.
Oh, okay, I got it. Awesome. So what is ratio level?
I didn't know ratio level as a type of variable. It's certainly a trap.
Oh, okay. So it's just a trick question. Okay.
Yes.
So awesome question. So let's move on to question number 2.
Yes. A researcher wants to measure temperature in Fahrenheit every hour in a month. Which level of measurement does he or she employ? Is it ordinal level, interval level, ratio level?
Oh, let me try this one. So
okay.
Firstly, measure temperature. So temperature is measurable. So this is categorical and categorical data. And also, this is rankable. So this is not nominal. It must be ordinal level, right?
Are you sure that temperature is categorical?
Category data is something that you can categorize, right? You can group them.
Yes. Could you group temperature?
Oh, okay. Yeah, you can't really group. Okay, so that eliminates binary and nominal. So there's only interval and ratio, but then the ratio is something that make up. So it's only interval, right?
Yes, it's more interval.
Oh, okay. So let me revise my thought to make sure that I got it all right. So there's 2 types of data is categorical and quantitative data. So because the temperature is cannot be grouped, so it is belong to quantitative data.
Don't say that. You are right. It is possible to group the values of temperature if it is hot, cold, or the middle, but here they say that the researcher wants to measure it every hour in a month.
Oh, okay.
So why it is quantitative in this case?
Ah, okay, I see. So every hour that is cannot be grouped, then this is the quantitative data.
Yes.
Okay, on quantitative, then we choose the ordinal. Interval level. Okay.
Exactly.
Yes. Let me try question number 3, and you can correct me. Select the correct point when choosing pie chart to present your data. So a pie chart is, from what I understand, it needs to be groupable. Right?
Yes.
So let me see, generally use show percentage or proportion. So the first one is correct. Useful to display data.
Yes.
Classified into nominal or ordinal categories. Let me revise ordinal that you have to order. So it cannot be pie chart. It could be like bar chart. Number of categories in the data is high. The data contain 0 and negatives. values. So the third one, number of categories in the data is high, right?
The number of categories in the data is high. You pick it.
Yes. Screen with you.
Okay, I stop sharing.
Oh. So that's all right. So you see, I select the first one and the third one. Do you think it's correct?
This one, the third one, I don't think so.
Oh, okay.
It is possible. It is possible. But
okay. Let's see what the answer is. This quiz I can do many times, so it's all right. So,
but you didn't pick the second one. Why don't you pick the second one?
Oh, use this displaying data to classify it into nominal or ordinal categories. Because I think if you want to show ordinal categories, then you would use like bar chart, because so that you can see like which one is the order of the chart.
Yes, you could use bar chart, but you could also use P chart.
Oh, okay.
A nominal variable, the sex. You can see what is the number of persons with male sex and number of female in the group.
Oh, okay, sure.
But you see, the third one, me, I think that a bar chart is better, because if you order the categories when they are high, you will see the top one much clearer with a bar chart.
That's true. That's true. Yeah. Choose the correct histogram chart. So left skew, right skew, symmetrical.
Or uniform.
What is left skew is more to the left, right?
Yes, should be skewed on the left side.
Oh, then this is left skew because clearly it's still on the left, right?
You know the meaning of skewed in this case?
No, I just see. That's what I guess. I don't know what's.
No, skewed in this case means that there are less values on this side.
Oh, okay. Less
on the left side, you see
that
there
is
are
right skew.
Yes.
Oh, okay. Awesome.
Symmetrical. The most of the values are in the middle.
Yeah, it's not symmetrical, because symmetrical it could be like
normal,
right?
Like a normal distribution.
Yes. Okay. This is the symmetrical.
Yeah, this is the symmetrical.
Use the correct data type of histogram. This is symmetrical. Okay.
Good.
What is the median of the set of data for 1 minus 2, 0? Okay, so median is basically the number in the middle. So we have to order. So let me, this one I think I remember. Basically we have the, we have 1 minus 2. Minus from, sorry, minus 2, 1. Oh, wait, minus 2, 1, 2, 4. So the middle one, the median is the number 1.
Okay.
Select answer. The ... is the middle value. So this is the median, right?
Okay. What is the, okay.
Okay. What is the variance for the data given? Variance. What is the variance?
Yes, for the data given. Yes, you know the formula for the variance?
The variance is, I forgot.
You should.
Let me remember. Okay, give me 1 minute. I think I remember. Let me write it down. So it's something that look like this. I don't know all the character in the statistic. Let me try. Ooh. So, okay.
The idea of the variance is to.
So that's all right. That's all right.
Okay.
Yes. Yeah, I think I remember. Let me try first because I just read that in the couple weeks ago. So basically, it's this character square. Uh, I'm just a big fan of, I just gave a presentation today actually
Okay.
on this learning curve. So, my way of learning is that I try to recall the information just right when we add the forgetting curve. So that's why I would be able to remember better. So that's why I'm trying to
Okay.
recall things, and I try to have you here with me to do the quiz together because you would help me to recall things that I forgot instead of searching for myself. So
Okay. Yes.
basically, I remember the character. I'm terrible at math. So yes, so this character minus this. Okay,
No.
wrong. Yes,
No.
please tell me.
Okay, I will tell you. The idea is to find how much the different values in the sample are far from the mean of the sample.
Mm-hmm.
So we take each value, we subtract the mean, and we take the square of this difference, and we sum up all this divided by the number of values.
Oh, okay. I think I remember. Hang on. Give me a moment. I think I remember. So basically, there is a variance. Like the first one is the square root, right? No, not this is not called a square root. What is it called?
It is sigma square.
Yeah, power 2, right?
Sigma power 2, yeah.
Oh, sigma power 2. So the formula is starting with sigma power 2, right?
No, it starts with yes, sigma, big sigma.
Oh, okay. Oh, it starts with big sigma. Okay. So if I remember like it's minus the mean, and then I forgot like what is the under of that.
Wait a minute.
Oh wait, because it's calculating the mean. So basically, you have to get like the range of the number -1.
No. A -1.
Or like
Yes.
this.
Yeah, it is -1 if it is on a sample.
Okay.
But they didn't say that it is a sample.
The U is the mean, right?
Yes, it's the mean.
Yeah, I forgot what this one called, but it's the mean, right?
Mu.
Mu. Okay.
Yeah.
And then you divide by the n.
You see what you wrote x minus mu. You should put it in. You should power it to 2 between bracket power 2. X minus mu. No. Remove this. Remove them. Yes. You put it between brackets. Yes. No. X minus mu between brackets.
Oh, okay.
Power 2.
Yes.
You should add in front of the first bracket the symbol sigma.
Oh, okay. This one, right?
Yes. It goes from it goes from 0 from the first element in the sample to the last one.
Mm-hmm.
Okay.
And then you minus number, right?
Yes. It is n when you know the real values and you know all the values of the population you are studying. But if you take just a sample in the population, you should divide it by n-1 because here have firstly computed an estimation. The mu value here is an estimation. So for
I have a question. Sorry, I have a question. So do we need to power this one? I remember like sometimes we have like this.
Yes, there is a power there. Yes.
Okay.
The power, this is the variance. When you remove the power, this is the standard deviation.
So I have another question. So I remember sometimes in school, like if we minus this, we can remove this. Is it the case or no?
No, you can't remove it. If you remove it, and you make the sum of them, you will have 0. Because the sum of the value, the difference between each value in the sample and the mean, it is 0.
Ah, okay. Yeah, that's.
If for not having 0, then we put the power. Either you could do something else, but it won't be 8 in the variance. If you remove the bracket, but you put absolute value since, you will have a difference, but there it is not the variance, it is something else. Alors,
I see, I understand now. So this is the formula for variance.
yeah.
So let's go to our questions. So what is the variance for the data? Also, we have to compute everything.
Yeah, you see, with this formula, it is it is a little more complicated to make the calculation. It will take you more time. So generally, we make a development, we develop the power 2, and we make simplification. And at the end, you have the variance equal the mean of the value in the sample power 2 minus the mean of the sample between brackets power 2.
Oh, okay. So the mean of this and power by 2.
The mean of each value power 2 minus the mean of the sample all power 2.
Sorry, I'm lost. How do you calculate the mean of each value? You can only calculate the mean of a range, right?
Yeah, it's not the mean of each value, sorry. You take each value power 2 and you compute the mean of this new series
Oh, okay.
of values. And then you subtract the mean of the original sample power 2.
Oh, okay. Let me try this. So,
Yeah.
actually, can you share screen to show me the formula just to be sure, please?
Okay.
I'll stop share. Okay.
Variance formula. Oh, sorry. Yeah. Not there. Okay. No. Okay. Yeah, you have variance the x equals to express mathematics. It's just the sum divided by the number of values.
Okay. Okay, try it to make sure I understand.
Yes, var x equals the expectation of x minus mu.
Sorry, what is the E in there?
Expectation.
Yeah, I don't know.
Mathematical expectation.
Yeah, I don't know what is expectation.
It's just the mean of the series of values.
Oh, okay, the mean of the series. Okay. So, okay, so let me try to do it to make sure I understand it.
Okay. You see here the mu, the replaces of the expectation of the series of value of big X.
Okay. Let me.
Random variable X. Yeah.
Okay. Let me try to do that. So, let's see. We have this branch. So basically, okay.
Haven't you installed Anaconda.
Oh, you start Anaconda.
Yes.
Okay, you want to do this in Anaconda?
No, you have installed Anaconda on your laptop.
Oh, I don't use Anaconda. I like either VS Code or PyCharm. But then if you want, because normally I have, if I really need to use, well, yeah, I don't really use Anaconda anymore because I'm in the engineer, you know, so we don't work with Anaconda. It's more for data scientists and data analysts. So, but then you also can use Colab. Colab is awesome, and you don't have to install anything. Because I do your book, because I do where your laptop is a MacBook, right?
No, this is a Dell computer.
That's computer. But then, what is the interface of it?
Dell with Ubuntu.
Ubuntu. Oh, okay. No wonder. I see the terminal. So, the easiest, well, the easiest for me. I don't know if it's easy for you. So I use.
No, it's the same thing. Just the same thing. Just over there, you just have to use modules and it will be faster.
Pardon?
But continue with Excel. You will understand better.
Oh, okay. Sure.
Doing yourself.
Okay. So okay, it does work. It's so much slower than I type it down. I hate doing manual.
Yeah.
So let's redo it.
Okay.
Okay. So basically, I need to. So this is my list. So the formula is.
First, you make a new series by taking the preceding power 2.
Yes. So this each variable I power by 2.
Yes.
Okay. So
then you make,
find the mean, right?
Yes, of each one.
You mean like for mean of this and this, like mean of this whole range?
Vertically, you compute the mean below each series.
Oh, okay. So
yeah.
So this is the mean, and
yes.
I power it by 2, right?
No, wait. You have to compute also the mean of the other one, the original one.
Oh, okay. So this is the original one, and this one is the one that power by 2.
Okay, so you take the difference between the mean of the series power by 2. You subtract the mean, the original mean, power 2.
Oh, okay. So this one I power by 2?
Yes, just this one.
Oh, okay.
Okay, yes.
So this is the answer. Oops, sorry. So this is the answer. Oh, okay. Wow, this is awesome formula. I didn't know because in the later lesson I have to find variance, and it was such a mess because I have to do every number I would like.
Yeah, it is very, you can make mistake with the other one.
Oh, okay. So this is, let me do it, original. This is the origin. Oh, that's really smart. Awesome, thank you. So question number 9, which of the measure I use to analyze the central tendency of the data? So let me guess. So the central tendency, this one, because these are like measure how far the value is further from the central tendency.
Yes, it's the dispersion indicator.
I see. A national achievement test is administered annual to third grader. The test and the mean score and how do I know this? Okay, hang on, let me read again. So the mean score is 100. Oh, because the standard deviation is 15. Oh, we need to check on the chat, right? I remember there's a Z-score table, right? So
Here you need a formula.
oh, okay. But though, like, I need to look at here to see, like, find the Z-score and this to find out the number, no?
No, here it won't be useful. Here you need the formula to compute.
Okay, can you show me the formula? I'll stop screen sharing.
The Z-score.
Oh no, the formula for this question.
Yes, the formula of the Z-score. You can type it on Google if you wish.
Oh, okay. So to find this, I need the formula of the Z-score.
Yes.
Oh, okay, I see. Z-score is the number described. Oh, okay. Oh, okay, I see. So the score, the mean, the stand. Oh, okay, I see now. So x minus u over, okay. So let me write down the formula is for the z-score. So the z-score is equal x minus, x is the test score, minus u is the mean over by standard deviation. Right? So, so the test score here is the question. The mean is 100. So x minus 100 divide by 15 is equal 1.20. So to calculate this, firstly, oh God, it has been so long. Okay, let me give it another shot here. So basically, x, oh God, minus, hang on, give you a second.
The mean?
Yes, the mean. Minus 100 over 15 is equal 1.20. Okay. So to calculate this, you move it here. So this, and then you this, and then you minus 100.
Are you sure that is minus?
Oh, plus.
Okay.
Okay. Sometimes I make silly mistake.
You are not. You don't have to make the computation. You can see the possible values, and.
Oh, that's right. You're right. So this is the one. Jeez.
Yes.
Yeah, you are good with this.
Oh man.
Yes, let me see. Oh, this is my first time getting all correct.
Great.
Also, thank you so much. So let's continue with this. So this one I already do, but I just want to redo it to make sure that I understand everything, because understand this module is very important for me.
Okay.
Oh, wait, let's do it in the next lesson. Let's try to do the coding. I can code, but then I don't understand the mathematical concept. So that is
okay.
So, so if you tell me the math, then I can code it to. Well, I hope I can code it because I'm terrible with
Okay, good.
Yeah, I'm terrible with math. I'm the one of the very few Asian that is so terrible with math.
Another one.
Yeah, that's a real story. My math teacher back in my high school don't even think that I'm fully Vietnamese because he have never come across with any Vietnamese that is so bad at math like I am.
Oh.
Yeah. Okay, let's. That's right. So I need to save this to my local drive first. Oh, okay. I didn't save it to my local drive. So save a copy to my drive. Okay. So let's set up the notebook. Okay. Part 1 mean square error. We consider, okay. Let's see. Let's explain this. We consider the simple mean estimation for distribution. Yeah, I don't understand what is that. Okay, let me try. Another estimator for the distribution mean is the mean max mean. Detect the yeah, I'm lost. Okay, let's just see what the problem asks. For this problem, you ask to write a function simple that experience calculate the MSE. Okay, so calculate the mean square error, right, of the simple estimator. Can you explain for me what is the mean square error? I don't understand what I read.
The mean square error, it is the difference between an estimator for an indicator and the real value.
Okay. Let me see. Yeah, I normally need some kind of visualization so that I...
It's a kind of variance.
Oh, okay. Mean square error. Oh, okay. Okay, yeah. I still don't understand. Every square. So sorry, I don't understand. Can I let you share screen so you can tell me more? I'm just.
Okay.
Yeah, I'm just not sure what I'm looking at.
Okay. So what did they say in this case? In this case, you know, normally it is not in this case me I made mean square error, but it was when we are doing regressions. Let's understand in this context first. They said we consider the sample mean estimator for the distribution mean. Another estimator for the distribution mean is the mean max mean estimator that takes the mean average of the smallest and the largest observed values. For example, they provide a sample. The sample mean is the sum of the values divided by the number of values, while the mean max mean is this one. Okay, they didn't give how to compute the mean square error. Okay. Mean square error. You try to predict the grade of children based on another variable we could have collect. You try to predict the grade of the children based on the grade of the parents, based on what the children eat, how the time they spend learning. And when we make the prediction of this grade, for example, I could try to predict that a child will have a grade of 10. If I got a value of like that, his parent got 10 in math, so I will predict that the child will also have 10. That's the value that I predict. And now you have also the real value for this kid. It could be like, for example,
sorry, I need to go away for 2 minutes. Can you wait for me for a little bit?
Yes.
I'll return in 2 minutes. Yes, thank you.
Okay, see you.
Yes. I want to turn off the stove, so.
Not much. Okay.
Yes, hello, I'm back.
Okay, wait.
Hello.
Yeah, yes, hello.
Yes.
Yes.
So,
see that. Yes, you got me?
yes. So, yes, let me, okay, so, write code for sample. So basically they are asking us to, they have the guiding step. Okay, let's do it then. If they have the guiding step, then I don't really need to understand the formula, right? I just need to follow the guide.
Okay, all right.
Okay, let me try to do that. Oh, okay. Okay, if they have okay. So the input are the uniform number of, oh wait, but I still need to know the formula to be able to do this.
Yes, indeed. So what you have to get is that the mean square difference.
So I still need to understand the symbol means. Okay, I'll stop sharing so you can share with me the formula.
No, I don't need to share. You just have to understand. Okay, the formula.
Okay,
you have just to understand that the mean square computes the difference between the value that we predict and the real value. For example, we have the volume of a drink in bottles. The average volume. The average volume could be, for example, 30 centiliters. But when we take a sample of these drinks, for example, we can take drinks and we compute the average volume, we got a value who could be less than or greater than the real value. The mean square error is the sum of the difference between the value that you have on a sample and the real value. We make the sum of this difference over 2, and we got the mean square error. It evaluates how our prediction is accurate or not. So in this case, they are asking you to generate 100,000 samples.
Oh,
so,
okay, hang on. Can I share screen for real quick? I think I kind of get what you meant.
Okay, sure.
Well, I don't know. Let me try. Just me, my math teacher gave up on me, so it's not that easy. So, okay.
Yeah.
So, basically, what you said is the square of difference between the actual and the predict is this one, right? So,
yes.
And I divide it by the n number?
Yes.
Oh, okay.
I was talking to you about kids. When you take one kid, you predict that he will have a certain grade in a subject, and he got a real value. Now you take the real value, minus your prediction for this kid, you make power 2. You have to make the sum for all the kids and divide by the number of kids.
Oh, okay. So, but I have question. What is this Mark doing here?
It is what? It is the sum, sigma.
Oh, so it's the sum of these. So it's
Yes, the sum.
like
Sorry.
this one, right? So we do.
Yes, exactly.
Oh, okay. And how do I calculate this thing?
It is a probability, but don't see as a probability. It is 1 divided by the number of elements in your sample.
Ah, okay, I get it.
Number of observations. Yes.
Awesome. So let me try this then. So, let's see. Let me try. So sample size is 10. Oh, okay. So basically, we need a sample size to be able to test this function.
Yeah.
There's a NumPy sample generate something like that. Oh, NumPy random. Okay. So this we import NumPy. Okay, NP. Okay. So wait. Okay, this is my lab. Let me close it. Okay, let's see what is the syntax for NumPy random.
They ask you to generate a kind of distribution. But remember the one they said?
Oh, so they asked me to generate the distribution.
Yes, a random distribution, a uniform random distribution between A and B. You know what is a uniform distribution?
No.
A uniform distribution between a range of 2 values, a lower and a higher is if the value is between the bounds, it takes 1 divided by B minus, divided by the difference between the 2 values, the higher minus the lower.
Oh, so basically I need to, sorry, so basically I need
0.
like uniform distribution for this.
Yes.
Right, this. Ah, okay. Oh, I didn't even know about this function. So, okay, so I need to, oh, okay, so I need to NumPy random uniform. So basically I can do this, right?
Yeah.
So this could be my sample. So basically I can get any number, right?
Yeah, you should have a look on the parameters of the function first.
Okay. So I have my sample.
No, this sample generates a sample between -1, 0, and is of size 1000. They said you a size.
Oh, okay. So
look to the parameters of the function. Have a look on.
Right, so this is the between the low and the high. So this one. Is it?
No. Read the docstring first. It will save you time.
Here, let me share with you the remote control. What do you mean by?
When you
I didn't hear.
push the tab space, the space key on your keyboard.
Here, let me give you the remote control. So, or you can share with me the screen so I can see what I do.
Okay, I will share you the screen.
Yeah, that is easier.
Okay, your notebook. Okay, so you are using NP random point uniform. So when you read the doctrine, the parameters are
yes.
the low and the high. So here low is A, high is B. The size, it could be an integer or a type of integers. If you enter an integer, it will be just the size of the sample. But if you enter a tuple, here we have, it could be of shape M and K. M is the number of experiments. And K is the shape of the sample, number of rows, number of columns. Here, I think you could give 1 row and 10 columns. Or if you wish 10 rows, 1 column, is your preference.
Okay.
So based on that, how you should generate your sample following the instructions they give you.
Okay, so basically they just give me the sample size, but doesn't give me like the low and the high. Then I need to find the points to have the low and the high, right?
You are writing a function. They give you the low and the high. The function, it's the function parameters A and B.
Oh, okay. So,
Yeah.
so the function that I'm writing is return the low and the high.
Yes, you will take the low and the high.
Okay. So how do I generate the random data set for my function then?
As you started, you just have to np.random.uniform. First is you give the low, which is I think is A. The height is B. Now the size. The first parameter is the number of experiments, and the shape of your sample it is 10. Either you make 10 rows, 1 column, or 1 column, 10 rows. As you wish.
Okay.
Yeah.
Okay, so we have, okay, so for the size, we need the column, hang on, let me repeat it to make sure I got the column, the row, and then what is the K, I forgot.
The M, it is the number of experiments. The N, it is the number of rows. K, it is the number of the columns.
Oh, okay, M is number of the experience. So the number of experience is 100,000.
Yes.
The number of column is, what is the number of column there? Just one, right? We don't have any other. So the number of row will be 100,000 because we have the 100,000 experience.
You say that if you give a shape of M and K, you will have M times N times K samples thrown. So M times N times K samples observation. In our case, we want to make 100,000 experiments. So we give here the number of experiments, 100,000. And in N, you could give the number of the size of the sample, 10 if you wish, and in K, you put 1.
Oh, okay.
1 sample at a time, yeah.
Yes, the symbol size is the row, number of row, and the column is just default 1 because we don't have multiple values, multiple variables.
Yes.
Oh, okay, I see. So, okay, so this is our K, which is, sorry, can you go up a little? So that is our size, and we don't have yet the low and the high, which is we are going to find by the function, right?
Yes, the function will provide it.
Oh, okay. Okay, so we cannot yet construct the, oh, can we construct the shape?
Yeah, you can make some tests. For example, A equals 0, B equals 1. For the size, you provide a tuple.
Oh, okay, I see.
Number of experiments. Size 10. To complete.
Oh, I see what you mean now.
Okay.
Okay, let me try to repeat that one again in my Colab to see how I do. Actually, I need to find out how to find docstring in Colab. I really don't know.
You said?
Let me see. Let me see how I get a docstring in Colab, because I actually don't know how to open the docstring in Colab.
So in Colab, you just have, from my experience, you just have to try to enter new parameters in the function, and the docstring appears
Oh,
at the top.
okay. So there's no pre-made docstring.
No.
Okay.
Yeah, docstrings.
I was so like amazed about Colab, and then now you tell me that there's no docstring. I'm so disappointed of Colab.
Yeah, docstring. Wait a minute.
Yeah, the docstring is very useful. Well, because normally I do it in other tools, so I didn't aware that there's missing of stuff. This stuff. So.
Wait, I will show you the doctrine.
No, I think you need to control and space.
Yes. You put comma, space, and doctrine appears inside the function.
Hello?
Hello? Yes.
Yes, I think I lost you. Can you repeat it again, please?
You enter in the function np_random.uniform. You do as if you are trying to enter new parameters, comma, space, and you will see the doctrine appears at the top of the function.
Oh,
and you
okay.
could scroll the bar to see the rest of the doctrine. You got it?
So I press Control Space, right?
Yes, in the function.
Yes. Let me show you what I'm looking at.
You should have something like this. You see?
Oh no, I don't. Let me show you.
Okay, go.
So here I have right. So Control Space. Yeah, that's what I have.
No, it's not this. Enter in the function. Between brackets. Between the brackets of the function. No.
Control Enter, right?
No, don't hit Control Enter. Try to enter something or push space. Push the keyboard space. The touch space.
Oh,
Yeah.
I didn't know until now. That's awesome.
Yeah. Now you can scroll. There is a scroll bar on the right side.
Oh, okay. So, oh, okay. Wow, this is awesome. I didn't know this. So, low we would write 1, and high we write like 10. It's all right? And the side?
Yeah. No. The low, the high. The low and high is the bounds of your uniform distribution. What are the bounds?
This one.
A and B. It is A and B. Okay. Here A equals 1, B equals 10. Okay.
Yes. And the size. So we said the size is hang on, m times n times k. So m is let me try to remember. M is the number of experience.
Yeah.
Time size time 1.
How did you write the number of experiments?
This.
Okay. No, you haven't to put times. You just have to separate them with comma.
Oh, I have to separate them with comma like this?
Yes.
Oh, okay. Okay.
You could have a look at the sample if you wish.
Oh, okay, sure. Oh, okay.
Try to look at its shape.
Pardon?
At the shape of the sample. Sample.shape.
Oh, okay.
You don't have to add brackets.
Oh, okay. Okay, so the shape is okay. So basically, this is the shape that we also put in.
Yes.
Okay.
So you have
okay.
100,000 samples of size 10.
Mm-hmm. Okay.
This is what you got. Now, you should generate it in the function.
Okay. So let me try.
No, first the docstring, that your function.
Oh.
You have to bring back a docstring at this place. Yeah,
Okay.
the comments, yeah, they put.
Yes. You mean like?
Yeah. After now you enter your code, you type your code.
I really don't like when things meet all like this. Okay. Yeah, sorry, I really don't like.
Just write your code below.
That's all right, that's all right.
No, let it in the function. Okay.
I need to make a docstring of this then.
Okay. Okay, good.
So about uniform sample size, number of experience output. Okay. So let's refer back to the mean, what is it, mean the square error. So basically it's the sum of it is formula. So basically I just need to get the predict value minus the original value times power 2 and divide by the number, right?
Yes, exactly.
Okay, so we need to make the loop. So
No, you don't need a loop.
because this means like for every value of n, right?
Yes, but first you generate the samples.
Sorry, can you repeat it?
Generate the sample as you did below. We can copy and paste it and replace the parameters by the function parameters. Copy sample equals empty random and paste it in the function. First.
Oh, this one is the sample. So you, sorry, I don't understand. Like, what do you mean by paste it in the function?
Yes, you have to copy the first line in this cell and paste it in the
Oh,
function.
okay. Ah, okay. I see what you mean now. So basically, but this is, I thought, just for testing.
Yes, you have to replace the argument of the function.
Oh, okay.
Random uniform.
Okay, I see. So, so for
first
for
replace the argument.
Pardon?
Replace the argument.
Repeat the
The
argument.
uniform distribution you generate is between A and B, not between 1 and 10.
Oh, okay. Oh, okay. I see what you mean here. Let me try to see if I do it here. So basically, my plan is that I'll write a function and then I'll take this input and the size, and here give me 5 minutes. Let me see if my idea work for element in the sample. So basically, it's the sample size, number of experiment output. Sample size is 10. So it basically the input minus the output, right?
You are not yet there. First generate the sample, then you will have to compute the mean square error.
Okay. So let's me copy this. So this is the sample. And then what, sorry, could you repeat what do I need to compute?
You replace 1 and 10 by A and B.
Oh, okay. Okay, I see now.
Okay. Now you have your sample. The next step is they say that output the MSE or sample mean estimator with sample size 10. How would you do that?
Sorry, which one that you are talking about?
They say you to generate this one is not the sample, it is the population. Replace sample by population. What you wrote before, don't call it sample, call it population, please.
Oh, okay.
Okay. Now they said you to compute the mean square error.
Yes.
To compute the mean square error, you need two values: the real value and the predicted value.
Yes.
Okay. So you have to go through the samples in the population, the samples generated in the population, and you compute the mean of the population, and you compute the mean of the sample, and then you try to see the mean square error between them.
Oh, okay. So so which value? So how do I know which one is the input? Which one is the original value, and which one is the value?
In this experiment, the original value is the mean of the population.
Oh, okay. So I need to
compute it.
The population, right?
You say?
So I need to find the mean of the population, right?
Exactly, yes.
Oh, okay. So basically, if we have the mean of the population, okay, like this, we have like how do I calculate this here? Oh, number by mean. Okay, so
No, the mean, the average. I was talking about the average. Okay, yes.
so right.
Yeah.
Let me see if it works. Okay, it looks like it works. Okay, so it looks like it works. So basically, I have the mean population, and then so this is my original value. How do I get mean of the predict value?
The mean of the predict value. Yes, the mean of one sample in the population.
The mean of one sample in the population.
Yes.
Okay.
Mean sample. Okay. No, mean of sample, it's not predict value, mean of the sample. Sample mean.
Oh. Okay. Sample. So basically, our sample is the size is 10.
So it's right? Is it correct?
No, not correct. One sample, it is an element in the population. You could take population square bracket 0, population square bracket 1, population square bracket 2, still 9,999.
Sorry, I'm not quite get it. Can you share screen to explain me more on this concept?
Okay. My notebook. Oh. Merci. My notebook. This is your population. Okay. You see, this population have a shape of 100,000, 10,000. So it is 100,000 samples. You take one of them, you just do pop square bracket 0. You have one sample of 10 values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here is the sample. You compute its mean. For this sample, it is 0.55. For another one, it means, sorry. It means 0.49, you see? So you have to compute the mean of each sample till 900, okay, 99,900 extra. I mean, when you have this set of means, you make the difference between this one, between the mean of the population and this mean. You take the at power 2 and you sum up of this mean square error divided by the number of samples. See why they say the mean of means MS square, MSE samples.
Okay, so basically I have to use the for loop for this. So for
you can use a for loop or look for maybe NumPy.
Oh,
functions.
okay, I can use while, right? While the element is smaller than the array, then I continue to apply the mean of it, and then subtract it to the shape.
Yes, it is a possibility. Yeah.
Okay, let me try that one.